I just wanted to throw one thing out about the sun since we were talking about the sun. Sorry about that. Oh, by the way, yeah, Rufus, you're absolutely correct. The moon is doing the same dance like the sun, going up and down as it circles, but we can get into that later. But anyways, what I was going to say was there's an elephant in the room that people have been talking about, just the general public, that NASA is not touching at all. And I just wanted to bring it to your attention. There's been over the last 20 years or so, there's been like, well, actually the people that have observed this has only happened in the last 5 years. But there have been literally people all over the world, like the tribes, the Inuit tribes in the Arctic region, and then there's citizens in the east coast of USA, west coast of USA, and other parts of the world have all noticed this. And what it is that they're all like, this one guy in Massachusetts, he has been with the same job for 30 years, and he's been taking the exact same road every morning for 30 years, and he swears that the sun is rising 15 degrees north of where it did like 20, 25 years ago, since he's been taking the same road. And then there's a woman on the West Coast who inherited a house from her grandparents, or her parents, sorry. She grew up in that house. And she said that she swears, because she has been in the house, as a child and a teenager, and now she's, middle-aged adult. And she said that the sun is literally setting 15 degrees north of where it did like 20 years ago. And then even the Inuit tribesmen, they've all been saying like, yeah, the sun used to rise on that mountain, and now it's rising, behind this other mountain. And when they point the finger, it's roughly 15 degrees difference. And then there's another guy, I forget which part of USA, but he said that the sun used to come in from window, on the left. And then now, 15, 20 years later, the window is coming in from a window that is literally 10, 15 feet to the right. So it's very curious that NASA is not touching this subject at all. And I keep reading comments in different articles online when people leave comments. And a lot of these comments were left on the articles that were talking about the actual movement of the magnetic North Pole. So anyways, it's a kind of a long story. And I think I know exactly what is happening, because it makes total sense on flat Earth, but we can get into that later.
Lily, you're the best, man. And I know why they're not addressing it is because they know that we understand that we would feel the effects of the Earth changing position in relativity to the sun if it were to move that way. And since they say we're moving in a centrifugal motion and you can't feel any of the effects of the movement of the Earth, they just pretty much have to ignore it.
Yeah.
To ignore everything.
Yeah, I mean, literally, when they say the magnetic North Pole is moving, because we can get into the whole pole flip things, because see, the science does tell us certain things. Like you can read the magnetite, the magnetite particles in the soil and everything. And of course, you can tell by the direction that they pointed that definitely there has been pole shifts. But the reasoning that the globers give us, of course, is completely inaccurate. And anyways, there's a unified theory that I've been working on, and I'll share with that. I'll share that on Twitter at some point. I'm working on writing it all down so that it basically tells you the reason for all of this stuff. So.
All right, appreciate that. Jonathan and Jenna's been waiting for a little while. But Jonathan, if you wanted to take it, you could go up next. Welcome to Flat Earth Fridays. What do you believe the shape of the Earth is?
Can you hear me okay?
Yeah.
Okay. The reason I asked is I'm plenty outside of the city limits of Indianapolis here. No, not if it's higher in the sky. So I found that interesting and I appreciate that. I would add that then we might want to take a look at its angular size if it's higher in the sky. And that can be done with a $100 Newtonian telescope with the sun filter on the end. It would not be hard to notice that the sun is. And
it's not very powerful. It's not like top of the line, state of the art, or anything like that. But it's also a gas. So the sun itself, you know, we have our own questions about that.
Sorry, I watched the 2017 solar eclipse through.
There was a guy. I'm sorry. Go ahead.
I was gonna say the problem with the eclipse is the well, the solar one anyway, is the shadow that is supposedly casting onto the Earth. Isn't it too small?
Why is that a problem? I'm curious.
Isn't it too small?
The moon or the shadow?
The shadow's smaller than the shadow's smaller than the diameter of the moon.
They could excuse that with that umbra penumbra.
Umbra penumbra. Those words sound funny together. Like bibbidi bobbidi boo or something. Anyway, so yeah,
That's what it is. Sorcery.
Yeah, maybe somebody should use it as a handle. So I mean, I can picture it in my head. I know you've seen the diagrams of the shadow and everything. How the moon would, the moon's shadow would cone down. It would neck down until it got near the Earth. And depending on whether the moon is in perigee or apogee, you get a annular eclipse versus a full eclipse, as I understand it. So since the sun is bigger than the moon, it will. You can imagine that no matter how far the moon is from the sun, you're always going to technically get these converging lines from the farthest edge of the sun, if you will, to the same edge of the moon. And then on the other side, you get a similar line that would be converging. And it just so happens that the distance from the moon to the Earth, those converging lines almost touch by the time they get clear. So I know you guys are going to tear that apart or whatever, but yeah, go for it. I'm curious to see what you guys say.
Hold on, did you give your number one belief or proof why you believe in the globe model? I missed that part.
Oh no, I just said I'm a glober. But my number one.
He's a skeptic of science as well. Like he disagrees with some of science.
Oh yeah.
So that's pretty dope.
But my number one. Yeah.
Well, I got a lot of moving around, man. Tell gravity to chill up off you for a second.
Fight back.
Fight the gravitational waves. All right, we can hear you. Go ahead.
If I'm still speaking, am I still speaking?
Yeah, you were just moving around a little bit too much.
Oh, okay. Jumping topics around. Okay. Well, I thought I was asked.
No, you were moving around too much. There was a lot of background noise. But yeah, we were waiting for you to tell us what your number one belief or proof was.
Oh, okay. My number one reason to believe the Earth is round would probably be the motion of the stars. And now, do you want a proof for the shape of the Earth, or do you want my number one proof for the heliocentric model?
Whichever one. Whichever one.
Okay. Well, for the heliocentric model, my number one proof is that I can go on to any number of apps, such as Eyes on the Solar System. I know that eyes are going to roll. But bear with me a second. So even though these are apps, even though this is computer generated stuff, it's still there's software running in the background that predicts the motions of planets orbiting the sun, and you can set the time and the date and the rate and all that stuff, and then you can zoom in on the Earth. You freeze time at any point in the future, say 10 years in the future. Freeze time. Stop the simulation. Zoom in on the Earth. Go to where you are, and at what time, whatever you want to make a prediction. Look up in the sky in that app and see where the planets are with relation to the other stars, and just, I don't know, draw a picture if you want to, but note the exact location, and then wait that number of years, and then look up. You can pick a time when the planet's in retrograde motion, something complex, something that's hard to predict. And I would bet that it would be right on the money. And so that just tells me that this heliocentric model is simply accurate. It couldn't make those predictions if it wasn't. I have a flat earth friend of mine, and we have great conversations. And that's one of the things I'm hoping he will do, because it kind of stumps him. It's like, yeah, you do have a point there. So that's probably one of the most compelling things that
I got you,
would agree
homie.
with any of you.
Get him, Alan.
Okay, so in regards to the heliocentric coordinate system and its correctness and predictive abilities, so there's a book called the Supplemental Ephemeris and it's the Supplemental Nautical Almanac and Nautical Ephemeris and all this stuff, right? And basically, what this book is it's a book written because people were asking, hey, how did you get all these corrections and angle corrections for the globe and all this for the Nautical Almanac and for the traverse tables for navigating and stuff, right? Because celestial navigation tends to match with maps that match the so-called globe, right? So check this out. In this book, they go over in detail everything. Now, basically, the difference between the globe and a plane comes down to what they call the deflection of the vertical. So if you're not familiar with what that is, they're basically saying that if you have two poles that are straight, parallel with each other, that one will be tilted, that they'll be tilted slightly away from each other due to the curvature of the Earth, kind of thing, right? So it's like, oh, cool. Well, how much is the deflection of the vertical? Well, when you get into the arc of the parallel and all that, that's where you get their spherical axis and stuff. So the difference between a plane and a sphere and the globe that you think that we live on is a difference in arc seconds. That it's like it's not even an arc second; it's fractions of an arc second. It's like 3 or 4 decimal places behind what an arc second would even normally be, right? So it's just absolute minuscule. So the important thing to note, though, in this book, though, that they go over is that they have 2 different coordinate systems that they're using to make the geocentric coordinate system. And the way they kind of present it is that the heliocentric coordinate system is the correct one, and that it's the first one, actually, right? But then when you look at the math they use, you see the transformation equations. Well, they're deriving the heliocentric perspective, center of the ball and all that and all that sort of stuff from the geocentric coordinate system. So the geocentric coordinate system mathematically supersedes the heliocentric one in terms of like which one came first, just by function of the perspective of the heliocentric way that they have it modeled out. I'll have pictures to go along with what I'm talking about, just so you can see the difference between the 2 coordinate systems, because it'll blow your mind. It's literally just a quick math equation that they just slip in there. So anyway, what they did is they went around the plane and took measurement angles, basically planar elevation angles to Polaris, right, starting with that in the north, and then as they got further away, they just plotted out, what kind of correction angles they would have to make, and all of that is done from their geocentric coordinate system. And then they have their an equation that they use for corrections. And in this equation, what they can do is they can either flatten or they can add ellipticity. So I'm sure you've heard the term, we live on an oblate spheroid and all this stuff, right? And how oblate is it? Where's the flatness? Well, funny you mention it. So this entire equation is facilitated on transferring planar correction angle measurements to the spherical coordinate system. So they just add a little what do they call it? Can't think of the word. Starts with an E. It's basically the curvature of the Earth is basically what they're adding, right? So they can flatten or curve whatever they need to on that coordinate system. And I'll have the pictures for you in 1 second.
So basically, not only because basically what Alan was saying, for all of those who's new to hearing this, if you're on a plane, there may or may not be any deflection, but on a sphere, you'll have this angle from one point A to point B, and they'll say that this is spherical excess because it'll be pointed away from each other. But that differential, after they make their corrections in a presupposed ellipsoid or a geoid,
Ellipticity.
Ellipticity is fractions of an arc second. Fractions after the corrections. And not only that, they derive their coordinate system, heliocentrism from a geocentric framework where everything revolves around us. So just imagine, like, how easy would it to be to do that and pull the wool over our eyes? Like, it's so crazy. Go ahead, Alan. You want to finish up?
Oh no, you're good, bro. You're killing it. I'm just copy pasting pictures right now to put on the jumbotron.
That's what's up.
Yep.
Please share the visuals. And then what I'm doing, I'm gonna take those same tweets up top and I'm gonna link them in the thread so you guys can double back and check these tweets out later. So just think about that, bro. Like these are these guys. If this is really what they did, the deception goes so deep.
Yeah, the difference between map and all that, because you got to think too, it's all in cycles too, right? So when you were saying earlier about how you can project out like 10, 20 years, well, they were doing all that way back in the day when all these ancient civilizations were flat earth cosmologies. The Babylonians were flat earthers, the ancient Hebrews, Israelites, all that, flat earthers, dog. And they were all doing eclipse predictions and all that stuff. They were all basing that.
Mesopotamians as well.
Not true. That is not true.
Oh yeah.
Yeah, it's not.
Okay.
I mean, I
Did
looked at
Bradley
this
just say
because
that?
yeah, thank you, Sacred, for exposing me to this, because I didn't know 4 weeks ago I didn't know a thing about this, and you told me all about the Saros cycles and all these ancient civilizations that predicted eclipses, and I read an awful lot about it, and I learned an awful lot, and I owe it to you for pointing that thing out, because I didn't know any of this stuff before. And the reality is that Saros cycles can predict that if an eclipse happens, a little more than 18 years later, another eclipse will happen somewhere else on the globe. They could never tell you exactly where. They could never tell you exactly when. And if you wanted, eventually someone figured out that you could get an approximate location if you assumed that the Earth was a globe and you realized that the Saros cycle was off by a third of a day. That meant that you could take the location of the previous eclipse, rotate around the globe Earth 120 degrees, basically a third of the Earth, and that would be the line on which the eclipse would show up. But they could never do what we do today. I mean, you go on to the NASA website today, and they will tell you to the second where the eclipse will be, how long it'll last. They show you the line. I mean, the amount of detail that is available today does not, it's incomparable to what the ancients were capable of doing.
During your
They'll even tell
research,
you
did
when
you
you-
come across the Antikytherian mechanism?
Yep.
Okay, they had all
Doesn't
that.
give
They
you-
had
it
all
doesn't
of that
give you-
plotted out on a stationary plane. The only
Hold on,
difference
what is it
is
called? Anti what?
the
Say it again?
Antikytherian mechanism. I'll link a video to it in a second. The only difference between the predictions made on that device and in a globe is they took the turning of the wheel to spin it, and they just said that we're the globe spinning. Like there's no, it's all on a flat Earth, bro. Anyway,
They were never able to plot the path of the shadow like they do today. Never. There is not a civilization that was able to tell you where the eclipse was going to happen.
and who told you that? The
And
current
they're lying.
civilization.
They're
That's
lying.
that.
No.
I'm
Okay.
just fucking with you, bro. You're good.
You're claiming something. Okay. You're claiming that ancient civilizations had this ability. I may be wrong. I admit that. I could
Yeah.
be wrong.
That's
All
all
you
good.
have to do is show me.
Yeah.
Okay.
So
show me
yeah.
a record
Go,
from an
okay.
ancient
Okay, I got you.
civilization.
I got you. Go back to the
Got it.
NASA website where you were looking for the eclipse predictions. Control F and look for Fred Espernek. When you look at that guy, you'll see how he derives all their eclipse predictions. They don't predict a single thing. Your boy Fred Espernek predicts them, and he does it based off of basically eclipse pattern tables from ancient civilizations that were all flat earthers. It has nothing to do with a glob and turning it 100 degrees. That's all heliocentric mythology, my dude. But it's cool.
You cannot get those numbers without assuming a globe Earth.
Word.
You can't get those numbers.
Okay.
You just can't. I mean, I don't know any other
I
way
got
to
you.
explain it.
Yeah.
Bradley, that's a claim. You can't make a negative claim without substantiating yourself, man.
Dude, but he
You're
can't
right.
explain it,
Okay,
so it's all
so
good. Anyway.
here's the thing that I can
It's a
say
belief.
though. You need to provide evidence that the ancients were able to do what NASA can do today.
Fred Espernek's tables are referencing to the ancient Babylonian stuff, all the stuff that I'm talking about.
How old is Fred?
All of their cosmologies, all the data tables, all of that comes from there.
Yeah. How old is Fred?
I don't know. Still
Is
alive.
he still?
What does it matter?
Because he didn't live 3,000 years ago. That's the point. Okay.
You don't have
I'm
to. You have
asking
it
again.
You didn't have to.
Bro,
You
yeah,
predict the Big Bang. Did you live in the Big Bang era?
Hold on a
Dude, that's
sec.
a shitty argument.
Hold on a sec.
No,
Don't
no,
dog
no.
pile him. I got
You
it.
guys are making a claim that the ancients were able to predict a precise location of eclipses the same way that we do today. And I'm saying, prove it.
Yes.
Show me.
Fred
document.
Espernek uses all of their data to make the predictions. It's an algorithm, bro. It has nothing to do with a glob. Like you got.
He did not. Okay, I have.
No,
actually
Alan,
looked into this, okay?
Don't you like
Yeah.
this level of discourse, Alan? Everything you come
No,
up with, he just says no.
dude, I sure don't.
Isn't
Like
that profound, dude?
it's running its course, but we're good.
No, it's okay. You guys can mock me for.
Nuh-uh,
I'm
but
not
you need
mocking you,
something
bro.
more than nuh-uh.
I just
You
gave you
gave me
straight.
the where to go research.
I just
Go
gave you
research it.
straight facts, and you said nah.
Okay.
So like, what's up?
If you don't interrupt me, maybe I'd be able to say something. Okay.
Continue, please.
So what you're claiming is this guy did exactly what the ancients did?
Yeah, NASA claims
Is that
that,
what you're
bro.
claiming?
Not only do I claim it, NASA explicitly claims it on their websites. They make no predictions on the eclipses.
Okay.
They put it all
Post
on
it.
Espernek.
Post it, dude.
Okay.
And I'll look at
Dude,
it.
Google it.
Got you.
Unlike you guys, I'm willing to admit when I'm wrong.
Yeah.
And
But you're not willing to substantiate your claim, dude. When you make it's better you say, I'm not sure of something. Do you have any evidence? When you say this cannot work on a flat plane, that is a claim. That is a claim. You have to provide the evidence. You don't say, prove me wrong after you make a negative claim. You got to substantiate your negative claim. So if you're not going to make a claim and substantiate it, don't make the claim. Just say, I don't know if it's true or false. Do you have evidence to support?
Okay. You can't prove a negative. You can't prove a negative.
Yes, you can.
All
You
right.
are not in this room right now. I looked around, I checked underneath the bed. You can prove a negative. It's the default position. That's a common misconception. The default position, you don't need to prove. A negative, you do.
What's
You are
the
wrong.
default position? That the Earth is flat?
I don't know what the shape of the Earth is. That's a default position. To say I know the shape of the Earth is a sphere or it's a cube, that's a positive claim. It is not a cube, is a negative claim. All of those have a burden of proof. I don't know what it is. It could be this or that. That's a default position. You're not making an affirmative claim, nor are you making a negation.
You're just saying you don't know.
All right. I posted 2 links. One is to the eclipse,
I'll take a look.
NASA website, and then the other is a screenshot at the bottom where all eclipses and calculations are by Fred Espernek, and he assumes all responsibility for their accuracy and their information. And then it has citations for all the tables that he uses to make the quote-unquote heliocentric predictions that could only work out on a glob. Anyway.
Wait, say that last part again.
GG's.
Exactly what you just repeated.
Yeah. What'd you just say?
That
Okay,
Fred Espernek. I just added on the same thing that you said, but I added it on as if it was a heliocentric truth. But anyway, check it out. Highly recommend. Anyway, what was your other big one that you liked?
A quick interruption. I wanted to say something about his question about the sunspots, whatnot, but I can come back.
My bad, guys. I was just looking at some of this content that Alan put up top here.
Oh yeah, sorry. I also included the transformation stuff in some excerpts from the book, and so you can kind of see what they're doing. So the big important thing to note on the screenshots, if you see the spherical picture and like the cylinder one, so on the left hand side, that cylinder would be the geocentric planar coordinate system, and then on the right would be the heliocentric perspective that they use for the quote unquote heliocentric predictions or whatever, right? But you can see that the difference between those is literally just a transformation, and the perspective of the center location of the ball and all that is derived from the geocentric coordinate system. Anyway. But yeah, that's how they got us, dude. They just did a bunch of transformations over a small, minuscule number, and they said it wouldn't be possible if it was a flat Earth. And it's like, not only is it super possible, the difference between the two models is fractions of nothing. Of fractions of our imaginations, really, dog. Because actually, the margin of error exceeds the spherical excess that they try and claim. That's the excess in the sphere, which is crazy. Because what they do is they take little small triangles and then they add them up together to make like a big triangle, using air quotes there, and then they kind of like hide their margin of error, and they're like, oh my god, wow, it's spherical excess. It's not. It's not. So.
Do they do the weighted value thing too?
Oh, weighted as fuck, brother. They weight that value the hardest.
So
yeah, dude, it's the best. And so the weighting actually gives the appearance of them. So they'll be like, oh, well, we got these raw measurements. We don't make any corrections. It's all raw data. It's like, yeah, dude, but it's like weighted. So like what, like nice literal false equivalence, right? So it's all good though. It's all good though. We're learning. We're all waking up to the deceptions and stuff, So
Damn
it's
right.
all good. They hid the sphere in there for a hot minute, dog. But now that we can control F search documents for keywords and then go from there, we just annihilated the 900-page document in like an hour and a half one day. It was awesome. Rest in peace, spherical excess. You had a good run.
Shout out to y'all for giving us technology again.
Yep.
Shout out to the engineers. Science likes to take credit, but it's usually people like Tesla that come out with this stuff. I wanted to ask a question, Alan. Earlier you talked about GPS, and one of the things that they tried to correct for it, you said the Sagnac effect is usually trying to make apologetics for the. Could you elaborate on that a little bit?
Yeah, so the Sagnac effect and the Sagnac correction are two different things. The way that they attribute the variance in GPS is they call it a Sagnac correction, and the way that they're trying to associate the terminology, I guess, is through rotation. So they're saying that the Earth is rotating, and the Sagnac effect is due to a rotation. So I guess that's kind of like the the wordplay they're trying to go with right there. So what happens is that the GPS will send out a signal to a receiver, and it takes its first measurement. That first measurement is done in what's called the ECI reference frame. That's stationary non-rotating reference frame. It's basically so that they can, it may or may not be where we live, right? And then so they get this distance from that based on what they think is the fixed speed of light, and then they transform it to the ECF reference frame. And when they do that transformation, it should be an invariant transformation because the speed of light, it should be fixed for blah 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 reference frames and all that shit that they say. So so the transformation should be invariant, meaning that it adheres to Lorentz symmetry. So like we've all heard these things like all reference frames are equally valid. There's no special reference frame. It's like, what does that mean? Well, the first postulate of special relativity is talking about Lorentz symmetry when it says that all reference frames are equally valid. What you do when you transform coordinate systems, you take the laws of physics with you, right? And the laws of physics have to be unchanged under transformation. So the way that GPS is specifically set up, being a time interval system all synced to the same time, and the assumed speed of light having a fixed value, this should the distances should transform invariantly, right? So it shouldn't have any problem. That they should be able to map it on a globe, on a triangle, on an oblate spheroid, rotating, not rotating, oscillating, vibrating, doesn't matter. The distance will be the same because the speed, under their assumptions, the speed of light is fixed, and the time interval system is synced precisely to the same time, which they've done a really good job of synchronizing it with. So this should absolutely 100% produce an invariant transformation, and it doesn't. It shows that there's a variance, and they call the corrections that they make to it segnet corrections, trying to associate it with some sort of angular rotation, blah 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 sort of thing. But that's not what's happening. What the way that GPS actually works is that the velocity of the receiver is already incorporated into it with the range measurement equation, and there's a proportional delay in which they receive the signal propagation, and it's proportional to their speed. So it's like literally as if there's a medium that electromagnetic waves is propagating to, and your speed relative to that medium is how you're going to receive electromagnetic propagation, like a variance relative to your velocity through that medium, the same way that sonar would work in water. So it's like, hands down, like one of the best proofs we got. Once you unravel that big snake's nest or whatever you want to call it. So yeah, there's there's a bunch of papers by a guy named Neil Ashby and a couple other people, and they go around promoting this segnet correction, GPS, Earth rotation situation kind of thing. But when they look at, there was two dudes, Petit and Wolf, who did a paper analyzing GPS data, and the data that they already got was segnet corrected, so-called. And they mentioned that in their paper. So like, even on the it's just so bad for them that they have to make a correction to that, because these are first order measurements, and if the speed of light was fixed in the way they said it did, it would be an awesome proof for them, but it's not. And they don't talk about this, and this is how that like the inner workings of GPS falsify everything they say, because this is explicitly how the technology works, and most people don't understand the intricacies of the time interval system and the transformation equations, and the fact that they take it in two different coordinate systems to do the measurements and then transform it, and they break Lorentz symmetry, and then they just don't tell anyone. Guys, they just don't tell anyone. How do they keep getting away with it? They're not going to tell you that they messed up, guys. And this isn't for like the flat Earth crew per se, but this is more for like the globe skeptic people that are like, how would they do it? Like, they're not going to tell you when stuff like this happens. They're going to try and obscure it. They're going to have Neil Ashby going around for 20 years, going to every publication saying that the segnet correction is due to Earth rotation. And it's like, okay, dude, cool story. All right, that's my 2 cents.
I found that was one of the biggest things to make me help consider ether was GPS and the atomic clock, the propagation. I'm sure you already know about the twins paradox, which is completely broken.
Yeah.
So the medium is a better explanation. I won't go through that, but I wrote down what everything you said. That was pretty cool. Thank you. Do you find that they replace a lot of the theories that they replace? It's gonna like they do away with the ether, but not really, right? They split it up in layers between the field and quantum foam. So every attribute of the ether gets split into different layers. Have you found out that you have to piece stuff back together from the standard model to get ether back?
Yeah, dude. So there's all kinds of like little low-key references to ethers and vortexes and stuff like that. So I'll send a couple of screenshots here after I talk about this. But yeah, so there's to start off with, there's the what is it called? The Bose-Einstein condensates, which is a vortex lattice structure that forms in a spinning quote unquote particle when they cool it down to a super cold, whatever that means. Basically these little lattice structures start to form when they try and spin the particle, whatever that even means, right? And there's screenshots here that I'll show. You can see these like these little vortexes start spawning inside of what they're looking at. It's crazy. So they got that whole thing going on, and then they also believe in something called the heliospheric current sheet, which is an interplanetary electromagnetic field or whatever that's generated from the sun that interconnects all the planets, and you'll never believe what it looks like, a giant vortex emanating from the sun, and it's very cool. But it's like, saying that there's an ether that requires electromagnetic propagation, they're like, no, can't do it. It's like garlic to a vampire. It's very bizarre when you see the overlaying concepts with like a Higgs field and all that, and quantum field theory. So for quantum field theory, they're like, okay, if we break every known substance down into like its own stationary field, and then when it's a particle, so called, that means that there's a vibration within that field, and that's when we observe like physicality to things, right? So like particles and whatnot. And so it's like, oh well, what's stopping us from like exploring this stationary field situation further? It's like, well, it doesn't work with our concept of gravitation, mass attracting mass, or the bending and warping of space time, dark matter and antimatter and dark energy and all that. Like, it doesn't work with any of that stuff, and we all know that stuff's true because otherwise heliocentrism wouldn't be true. So we can't really proceed forward with quantum field theory other than just to say it's a nice predictive model to say that things are in a field, just for funsies.
Yeah, I got some questions as I'm looking at this stuff. Can I interject, or do you want me to?
One second, Bradley. I do want to hear from you, but Unknown has been super patient. So let's hear from Unknown real quick. I appreciate that, Alan. And Bradley, just keep that whatever you have to say in mind. Don't forget, and we'll double back to you after we hear from Liliana. But go ahead, Unknown.
Hey guys, thanks so much for bringing me up. I've just been listening for like, I don't know, 30 minutes right now, and I don't know if somebody already asked this question. I'm actually believe in a globe. I went through the indoctrination system of the education system of the West, and I was taught about the uh, way they came about the globe model of the guy who was in, I don't know, Europe, who put a stick in the ground and took the shadow and did a stick in the ground in Egypt, and that's what I was taught. So I've been getting a lot of flat Earth stuff in my feed as of recently, and there was one question that made me doubt or think was there's a massive black hole in the center of our galaxy, and then our sun is flying through the around this black hole at, I don't know, some super fast speed, and then our planet Earth is rotating at a super fast speed, and then the moon is rotating around our sun without ever showing the dark side of the moon ever, and then the gravity of the sun is holding our planets, and they're all rotating and flying around the sun while it's flying around the dark hole. So I don't know if my question is appropriate for the people on the stage here, but if maybe somebody could enlighten me on that stuff. I'm just honestly learning from what you guys are saying and what you guys got up on the jumbotron there. So that's my question. Thank you.
Lots to unpack there, my dude. Let's see. Where should we start off with? Eratosthenes and the sun. So I got a really good video you should check out for Eratosthenes and the whole narrative behind that. So there's the problem with the Eratosthenes thing, and the way that they solved it was by saying that the sun is 93 million miles away, and there was no justification for doing that. And then from our perspective, where we say it's not a physical object, like we explain the same situation, but just with a different mechanism, right? So we have the azimuthal grid of vision. So every person will see the sun, relative to their field of vision. So there's gonna be like a slight displacement. So the kind of the imagery that I linked earlier, where the sun, when you plot it out to the latitude, makes a 3D hyperbola in the sky, meaning it just makes a big donut in the sky if you were to plot it out to the latitude and then over 360 degrees. So it's not a physical object, and kind of coming to that understanding really alleviates a lot of the, I don't know, like where you're trying to hold on to, like, well, how is it 93 million miles away, and how are the shadows and the parallel rays and all this stuff, and it's like there's no justification for it other than the ad hoc explanation of it being 93 million miles away, based on two shadows, right? So like no third shadow or nothing, right? But then like I said, when you get into the third shadow, that's where they just move the sun 93 million miles away, and that's where we're starting to come to the realization that we have an azimuthal grid of vision, meaning that each person has a local field of vision, and what you see is in the sky is going to be put in your field of vision relative to where you're at on the Earth. Oops, sorry about that. Hit my mic. So your other question about black holes and stuff. So let's talk about the concept of a black hole, right? Because that would be the underlying mechanism that's facilitating all of this motion, right, so to speak, within our local galaxy, right? So the concept of a black hole comes from something called a singularity, and that's when the mathematics break down in an equation. So a lot of the big common equation that they use for a lot of space-time stuff and Einstein and whatnot is they use what's called the Schwarzschild metric. And the Schwarzschild metric has a certain what's it called? What's the word I'm looking for? I don't know. I can't think of the word, but it has a certain like limit on what it can describe, right? In terms of mass and size relationship, right? And if something goes below a certain point in size, and if it's due to how gravity works and all that, as it gets denser, it breaks the equation basically. So it gets too dense, and then the gravitational field, quote unquote, breaks the equation. And they describe this in this like eloquent story of like the curvature of space time becomes infinite, and we don't know what happens, and there's this singularity, and it's so strong that it even pulls in light and it distorts matter around it and all this stuff. It's all out of the math equation being broken because they're trying to use it to describe something that it can't do. So it airs out. It produces a singularity, right? It's like equivalent to dividing by zero. It just produces nothing, right? And instead of going, oh, the equation is broke, it doesn't work, they turned it into this fantastic story, and they gave life to this entity called a black hole. And then not only that, if they use a different metric to do the calculations, the Kerr metric, for example, which accounts for angular rotation angular rotation and whatnot, then they have a rotating black hole just based on the collapsing of the mathematics used to describe the phenomenon. It's completely abstract. It has no physical value. So a way that you could think about a singularity kind of is if you were to, what would be a good way to describe it? So if you just, okay, hold your index finger and your thumb together, just kind of like, how close can you get them before they actually touch? Imagine that you could never get them to actually touch, and you could always just perpetually get them slightly closer but never touching. So that tendency towards zero, that singularity, that's the concept of a singularity that they're describing, that's breaking space-time, that's causing this infinite curvature and all this stuff, that they're attributing all this stuff, right? It's just pure abstract mathematics. And that's a hard one to let go, because black holes were cool as hell. And, we got all these awesome movies and all these, Event Horizon. Black holes are the shit, man. It was a tough one to let go. But yeah, it's literally
is a fun one.
Yeah, Interstellar. Yeah, it's literally just a math story. And then based on which math equation you're using to describe the phenomenon, i.e., which way you break the equation, determines what kind of rotating or stationary black hole you get. It's bizarre. And then yeah, sorry, go ahead. You're good. I said a lot.
No, Alex, I just wanted to add on to that. Did you also hear about how that breaks the gravitational model for them? So now they have a galaxy rotation problem where the stars that are closer to the center of the mass are spinning in the same velocity of the ones at the edge of the galaxy. Well, that's a problem, because if that's they fixed it with dark matter, but if Ken had a great presentation, shameless plug. It's pinned to my page that talks about modus ponens, which I will and how that relates to scientific testing. So if the gravitational model is correct, then the galaxy rotation problem is the antithesis, and it breaks it. And instead of just saying, like you said earlier, oh, well, this broke, we got to go back to the drawing board, we create a whole nother theory. It's like a Hegelian dialectic. It's an antithesis of it. We're just going to create a whole new synthesis of that. So have you found a lot of that where it's like a win-win situation where you get rid of a null hypothesis by bringing it into another theory? And if so, share, if you could share that, please.
Shoot. Let's see here. I'm sorry. What was your question? It was
the galaxy rotation problem. Do you see that they're trying to fix gravity, like the problem with broken gravity? If their gravitational model is correct, then the galaxy rotation problem breaks that. So they got to invent more dark matter. Well, that just negates your null hypothesis. You have no more null hypothesis if you can just say, well, dark matter that we don't measure yet or see yet, touch yet, we
Oh
can't.
yeah, dude, it's insane. It's insane that they did that and nobody called it on them, and now that we're calling it on them, they act like we're retarded for questioning it. It's actually insane. No, you're dead right. So the galaxy rotation, based on the because this is what they do. They look at a galaxy, right, and they go, okay, it's this bright, so therefore there must be this many stars in it. They do this whole mass distribution thing based on the luminosity or the magnitude of how bright it is, basically, right? They're just they deduce it all back to that with their noble ladder and stuff, right? And they found that based on their assumptions on the noble ladder, which is how they're deriving how much mass should be in a galaxy to begin with based on its luminosity, right? So they found galaxies that weren't as bright and they were spinning too fast for how much mass they should have had or whatever. So they said, oh, so naturally the galaxy shouldn't have been able to support itself and it should have ripped itself apart, but it didn't. So that's where they came in with an unfalsifiable claim that there's something out there that doesn't interact with the electromagnetic spectrum, but it somehow facilitates acceleration and deceleration to the point where it holds a form in place of mass, even though it doesn't interact with light in the way that that would be meaningful, that would enable us to see it. So in regards to that, right? So check this out. They say that so dark matter, essentially what they're saying is that dark matter only interacts with the gravitational field. Okay, cool. Only interacts with the gravitational field. That's great. So that would also affect the light. That would also affect like gravitational lensing and all that kind of stuff. So there would be indirect effects of dark matter that we could see other than just the ad hoc explanation of the galaxy rotating faster. There would be additional effects that we could see, that we could analyze, that they can make predictions off of with redshift and whatnot. Because if it truly is affecting the gravity field in that way, well, guess what, dog? Einstein's whole theory is based on gravitational fields. You should be able to reverse engineer exactly how much dark matter is in that area that's facilitating all that, and then you should be able to confirm that through spectral readings. And they never do, never have, never will, and they just say it doesn't interact with light, but it does interact with the gravitational field by the way that they're describing it. And the gravitational field in their model in their belief system interacts with light. So where's your spectrum shifts at, lads?
And if that gravity is stronger than the black hole center itself, and that can cause Hawking radiation, what the fuck is going on with dark matter? That should be all kinds of weird shit going on with light. So everything they fix something, they break something else with that fix. And lastly, I just wanted to put two things up in the next. I don't know if you ever heard of Hatch, Mr. Hatch. He goes into electronic theory conferences along with Steven Crowder. I don't know if you ever heard of him as well.
Mm-hmm.
So yeah, that goes into what you were talking about with the relative observer effect with the GPS. He's actually a GPS expert.
Mm-hmm.
So he deals with it. Ron Hatch, if you ever heard of him.
Yep, I got his book. It's
oh, you got his book.
Yep, Escaping
nice.
Einstein or something. Yeah.
Sweet.
Yeah, if you want to check it out, it's pretty decent. It's got some good stuff on there in regards to the Sagnac effect.
Dope. Cool, man.
But yeah, he's got some interesting stuff to say about gravitational fields. He actually has his own ether theory too, but I haven't really read too much into it. But yeah, he had a whole thing going on. I think he might have died recently. Peace be upon him, if so.
Hey, and just real quick, just a shout out, Mr. Xavier's doing a Sunday Space Standard Forum. In order to grab a mic, you have to stick to the protocol, stick to the etiquette. And what is it about critical thought and coherent arguments, Mr. Xavier?
Yeah, it's just real quick. I'll make it 30 seconds. It's about standard form arguments. A lot of times when we have these conversations, we end up talking past each other a lot. So again, shameless plug. My pinned tweet has the space is 1 hour. Ken talks about some of the rules of inference you talk about when you engage in these conversations, engage in logical inference, and how do you formulate an argument with that. If Mr. Xavier has an XY chromosome and those who have an XY chromosomes who are adult are labeled men, then Mr. Xavier is a man. Simple, clear, concise, format. If those premises are true and it leads to a conclusion, then these conclusions are automatically true. And why would you want your arguments to be automatically true? I think those come in handy, right? It's pretty important. So if you learn how to put them in standard form and their sound, that they're really cool. So I'm going to do a format with just that. No free form conversation that goes all over the place. You stick to one premise. We don't get off of it till we finish that. So yeah, thank you for that plug.
Yeah, I've been over there. It's a dope conversation. So looking forward to it. Still Flash Sundays, Standard Forum Sundays, Flat Earth Fridays, and we pushing into stationary Saturdays. We rocking. Still tapping in the ether with me, proud.
Yeah, you already know I'm battling the mention bots.
Oh,
They
no
not
way.
active. They ain't in here. Hey, yo, Bradley, call eye level. Call Yuval. If I do it, he gonna say I'm antagonizing him. But you're a Glober. Go get your backup.
Yeah, Bradley, Peter, go get your guys.
Oh, and Conspiracy Smasher. He been crickets since
No
12
way.
hours. 12 hours this man been crickets.
Not
He
the
actually
Conspiracy Smasher crickets during Flat
under
Earth Fridays.
commented under Ted's repost of the space to talk shit, but never pulled up. So yeah, I'm sorry. I'm doing recon, guys.
It's been on us all week too.
Appreciate it. Intermission, brief intermissions coming soon. Stationary Saturday reset.
Yeah, I'm looking at this astronomical algorithms that I got to via the NASA website that Alan linked me to. It's over 400 pages long, and the chapters that have to do with eclipses are chapters 2, 3, 7, and Appendix A and B. And there's a Fortran program too. So there's a lot to go through here, but I've been looking through it, and I quite honestly, Alan, I don't see anything about what you're talking about. Every formula, every process that he's talked about so far has to do with a globe Earth. So maybe you can point me to a particular page in this thing that would help me understand. But it's going to take a while.
Yeah, no worries, man. I don't have a specific page for you.
My bad, guys, tweeting over here. Who was up next? Did we? I think it was Leliana. Go ahead, bro. You kind of choppy right now.
Who's up?
Oh, I want to make sure I can hear. I just want to make sure I can hear Prop. Prop, you
Can you
might
hear
good?
me? Sorry, I don't know who's up.
Oh my goodness, ladies.
Who's speaking right now?
Go ahead, Lily.
It's on you, Lily. It's
Oh,
on
okay.
you.
All right. Can you guys hear me? Sorry. Can you hear me?
Loud and clear.
Okay, cool. Yeah, I wanted to answer that question that gentleman had who was talking about the sunspots and whatnot. So yeah, I just wanted to tell you that, I know that you were talking about having all the instruments and how, yeah, I think that we honestly, not we, but I think globe earthers totally believe in the infallibility of instruments like telescopes and things like that. And they're not infallible, okay? Because at some point they could make mistakes, so we wouldn't know. So they could be right 90% of the time, they could be right 80%, 99%, but they're not infallible. So I just want to convey that. And then the second thing is that I think that, to think that the ancients knew less than us is really not fair, or I don't think it's even objective, because A, we don't know what they really knew or didn't know. But B, you have to really open up to the idea that they might have had way more common sense and also just ways of deducting things because I believe that we're really dumbed down. I think that the ancients were inherently just naturally more intelligent. They knew how to use critical thinking better than us. Their pineal glands were not calcified with fluoride like ours are. So let's not think that the ancients didn't know. As far as I can tell, from what I know of my own history, of my heritage, which is Vedic, and it's super, super ancient. These are people that invented the zero. These are people, the Sanskrit language is supposedly like the most ancient language that is the ancestor of all the Indo-European languages, et cetera, et cetera. And my point is that they were avid astronomers. They completely accurately have been predicting eclipses for thousands of years. There are books there that are thousands of years old. And just because Western scholars say, oh, this was written, 1,500 years ago, that doesn't make it true, because they have been keeping time by the constellations. Excuse me. And so you don't make mistakes. If you invented zero and you're keeping time by the constellations, you definitely know the difference between 100 years and 1,000 years. So my point is they knew a lot. But anyways, going to the sun, having the sunspots, according to the Vedic paradigm, and actually to get into how they came to this conclusion is a little long, so I won't give it to you. But what you can know is that, astrophysics of today have told us that several stars, like magnetars and, various kinds of stars, they're some of the most electromagnetically powerful items that they've ever seen in the universe, right? So basically, there are stars that are beaming out incredibly powerful rays that, according to the heliocentric science, the regular, astronomy today, they're light years long because they're that powerful, right? Because they measure the power, whatnot. Anyway, so let's just say that they're very powerful beams, right? So now, if you think that all the astronomers, especially the ones in university, are just able to go and have time on these multi-million-dollar telescopes and just go and check out anything that they want to check out, that's not how it operates. They have to have very specific permission, to which the computer will be, aligned to that particular part of the sky that they are allowed to explore, et cetera, right? So it's not like the astronomers and astrophysicists of today have free range, to just go and explore anything they want with those multi-million-dollar telescopes, which, by the way, are not completely infallible, I'll remind you. So basically, as far as the Vedic paradigm goes, and as I said that, it's too long to explain, so I'm going to try and write it down at some point and present it to you guys. But here's how it works in the Vedic paradigm. So yes, the stars are shooting out, various stars, multiple stars are shooting out very, very powerful beams. And in fact, all the luminaries, all the planets, quote unquote, including the sun and the moon, are all a result of these beams that are shooting out from various stars in the sky, in the dome, that come together at certain points and create these luminous orbs, which are basically plasmic in nature. And each of these orbs are at a different altitude within the dome. So you have to think of these layers, dome-shaped layers of their mixture of various gases and force fields. And depending on which band or which layer of the gases and force fields that these stars are going and merging their beams, a different orb is going to be created. So the moon's layer is the highest according to Vedic astronomy. And then right below the moon's layer, which is, hundreds of miles wide, right? The layer, if you had to just measure the altitude of the layer, it's hundreds of miles wide. And then underneath that layer is another layer of gases and force fields. And that layer is where the sun operates. And we're not talking about the horizontal orbit. We're just talking about the altitude of these gaseous and electromagnetic domes within which these orbs are moving. So literally all the luminous orbs are tethered electromagnetically to various stars in the sky. And actually Vedic astronomy even tells you which stars are tethered to which planets are tethered to which stars, which I'm not going to get into right now because it's all very long. But basically, that's how it is. And so to explain the sunspots and just the way that the sun is, you can just imagine if there's various stars beaming those powerful, invisible radio beams, because it's in a frequency that we cannot see with our eyes. And if they're being seen by some radio telescopes, we're not being told about it. So if you think that, all of astronomy and everything that they see through these various exotic instruments like radio telescopes and stuff, if you think they're actually telling us everything they see and they know, then I don't know what to tell you, because they're not. A lot of it is hidden. So we're not the first people to, to understand all this or see all this or to have technology to do all this. But basically, if you look at all the luminaries, they're all moving along with the sky dome. And if you start drawing lines to these stars, once you get the names of them, you will see that they're literally electromagnetically plugged in. So what you're seeing in the sunspots is a few spots here and there that, the beam is not there. And so it translates as being dark. But it's just because that portion of that layer of gases and electromagnetic field is not completely lit up. So anyways, that's kind of just the short version of it.
Can I respond? Can you all hear me?
Yes, sir.
Yeah, go ahead.
Oh, okay. Thank you for that explanation, Liliana. That's way over my head as far as that theory goes, and I'm curious to read a little bit on it. If someone can point me out to some literature, I'd be interested just to look at it. So yeah, I don't really care what scientists are doing with their big expensive telescopes. Really, I'm really interested in what all of us can do with our budgets in purchasing a simple.
So like the math does break down, but it breaks down only in the very, very center of the black hole near the singularity. Inside of the black hole, away from the singularity, no, it's only in the hypothesis.
Or the galaxy rotation is a problem. The rotation itself.
To say thank you for the clarification on the black hole and rotational clarification, because the subject was kind of mixed together with what dude was saying. So thank you for clarifying that. And then also in regards to the interaction with dark matter, so it would affect the gravitational field, right? Because it's all what it's facilitated by. And if the gravitational field is affected, then there would be spectral readings to correspond with that amount of missing mass for the gravitation, right? So they don't have that.
Well, yeah, but when mass is spread around, like we have the Oort cloud on the outskirts of the solar system, it doesn't gravitationally lens in any observable, or it does in very minute ways that we cannot measure. But we, in our ability to measure gravitational lensing, requires a significant mass in one place to observe it. So in the generic case, every single atom creates gravitational lensing with its mass, but it's so minuscule that you don't see it. So if it's spread around, you don't see it. If you put the same atoms all very closely together, when you pack them, it creates a large deformation to time-space. And that's why we observe gravitational
So
lensing.
if the overall mass of the galaxy is being held together from dark matter, that missing mass distribution, the light emanating from it will be spectral shifted, corresponded to how much gravitation is.
Yeah, but it doesn't.
Is there,
right,
but it doesn't. So it just shows like
Yeah, it doesn't.
Shit. So like
that's why we call it dark matter.
Negative.
That's the only reason why we call it dark.
Negative. You're not understanding. So the gravitational field, right, is what the mechanism for relativity to facilitate the wavelength and the frequency change for light, right?
Mm-hmm.
And the dark matter is altering the gravitational field such that it is facilitating acceleration and deceleration within the system so that it does not rip itself apart. Thus, there is some sort of mass there that is completing the gravitational field for the system. Yes or no?
No, actually, yes and no. So if
Well,
I
it can't
take
be
the
both.
mass,
Can't be both. Can't
okay,
be
so
both.
no. So I'll go with no, and then I will explain. That's fair
Okay.
enough?
Sure.
Okay. So if I take the sun, which has significant mass,
Mhm.
and I break it apart into individual protons and I spread them over a large area, it's the same mass, but the deformation to space-time that it causes, it's minute in every little part of it, right? But if I take the same mass and I pack it into the size of a peanut, which would be, black hole would be like, I forget how big for the sun, like 30 feet maybe. If I pack it tightly, then it's going to deform space-time in that spot very significantly. So when you shoot light through that deformed space-time, so to speak, then you're going to see lensing. You're going to see it bend. But if you shoot it through a wide empty space where you spread around the photons of the same mass, you're not going to see that.
Yeah, so your analogy is slightly off though. So the way that you would be, the way that you kind of describe it would be, um, you have the sun as individual particles, right, separated over a wide area. And then there's nothing in between those particles, right? That's not the case here. So in between the space for each particle, there would be the relevant stars of the galaxy, right? So it would overall facilitate, the missing gravitational force in the way that would change the spectrum of light to correspond with that amount of density in the system, right? So like it's not there.
Well, you wouldn't, because it's roughly uniform there. So when the light travels, us humans wouldn't be able to tell if it's affected or not, because there is no visible dent in time. If you imagine time-space being kind of compressed or dent in it caused by concentrated mass, and we see it only when the light traverses that spot. It kind of bends over it. When this mass is spread over, we don't have like a reference because it's all smooth. It smooths out, we would say mathematically.
So based on the luminosity of the uh, galaxy, right? They get their mass of it, right? And they can take spectral readings from that, and
That's right.
and
Yeah,
they can deduce how the light is interacting with the gravitational field as it's escaping the system. And if there were a
that's
dark
correct.
matter, and if there were a